So they're wanting us to sketch the graph of this parabola using our knowledge of zeros and multiplicities. So again, when we say roots, that's the same thing as zeros. So in this case, we have a 0 of 3 with a multiplicity of 1. We have a 0 of a -2 with a multiplicity of 2. And we have a 0 of 5 with a multiplicity of 3. So those are our roots or our zeros. We also want to know the y-intercepts. And I know it says plural there, but really, if it's a function or parabola, we're only going to have one intercept, right? So a y-intercept, that means our x is 0. So if we plugged in 0, here's the little work off to the side. If we plugged in 0, f of 0, we would get a -3 times 2 squared times -5 cubed. And that would give us 1,500 for our y. I know it seems awfully large, but again, we are sketching the graph. The degree, notice there's the multiplicities. We can add all of those up. We have a multiplicity of 1. The second x shows up twice, so that gives us 3 x's. The last 0 shows up 3 times, so 3 more. So this gives us a degree of 6, so we know that it is even. And then the end behavior, notice the leading coefficient is just a 1, a positive 1, and it's an even polynomial. So that means it's going to do this. So as x approaches either positive or negative infinity, the graph is going to go up towards positive infinity. So let's just kind of take a quick sketch of what we think this guy is going to look like. Again, our zeros are at -2, 3, and 5. And our y-intercept is way up here, but it doesn't have to be to scale. Again, we're just sketching it. Our y-intercept is way up there at 1,500. So we know it's of degree 6, and it opens up. So as we're going to this first 0, x equals -2 with a multiplicity of 2. Remember, our multiplicity, if it's even, it's going to bounce. So we know we start upwards. We're going to bounce off of -2. We know it crosses the y at 1,500. We know the multiplicity of 3 is 1. So it's going to cross 3, but not really flat, right? And then 5 has a multiplicity of 3. So it might be a little bit flatter there at 5. I didn't quite hit that. So again, it is a sketch. It is not every single point just exact, but we've got the big pieces. We have the end behavior. We have all of the intercepts. The degrees are correct. So it's just a nice quick sketch of the graph. Now we're asked to find a possible equation for a 5th degree polynomial. So that's important. We know how many x's are going to be multiplied, where we have roots of multiplicity of 2 here and multiplicity 1 here at x equals 2. And then it goes through the point 5, -576. So 5th degree polynomial. So we know we have f of x equals some coefficient a. The first root of multiplicity 2 is x equals -3. So that would give us an x plus 3 squared, multiplicity of 2. A 0 at 4, so we have x minus 4, again a multiplicity of 2. And then another 0 or root of a multiplicity 1 at x equals 2. So we have x minus 2, technically to the first power. So 2x's times 2x's times 1x would give us x to the 5th. So we do have a 5th degree polynomial. But again, we have to find that a. So we're going to use our point 5, negative 576. So this time they didn't give us the y-intercept, but we can still use that point. So the y value is negative 576. We don't know the a, and our x's are 5. So 5 plus 3 squared, 5 minus 4 squared, 5 minus 2. So 8 squared is 64. 1 squared is 1. 5 minus 2 is 3. Equals 192 times a. So that means when we divide by 192, we get a to be a negative 3. So our possible equation for this 5th degree polynomial is negative 3 times x plus 3 squared times x minus 4 squared times x minus 2. Now in that example, they actually gave us the zeros. They listed it in words, and then they gave us another point. We can do the exact same thing if they give us a graph.
So check out our next video.